bonjour, merci, excusez-moi, je ne parle pas en français, so I'm going to speak in English, and unfortunately. I'm going to talk about climate change and wildfire really from a global perspective. I'll throw in some comments from Canada, maybe the United States, and maybe speculate on the Mediterranean, but it's going to be a very broad scale. Some of the things you've heard already from Meteor France and from others. I'm at the University of Alberta. I'm part of this Western Partnership for Wildland Fire Science. You can Google us. We're there. The picture shows Slave Lake, Alberta, a community about 2 hours drive north of Edmonton. And this is from May 2011. About 500 structures burned. Cost was over $700 million. It was the third largest natural disaster in Canada. And the weather was, winds were about 100 kilometers per hour. And RHs for this part of the world were around 14 or 15%, which is low for our part of the world. And RHs did not recover during the night, which is very unusual for this part of the world. This is boreal forest. And it roared right through town. And yeah, it was quite devastating. So I'm going to talk about fire. I'm going to talk about climate change, impacts of climate change on fire, and then briefly some options. This is a MODIS satellite picture showing this day, May 15th, 2011. And do we have a pointer, a laser? Wait. It's okay. C'est bon. This is the community of Slave Lake burnt. This was taken just before the fire ran into town. This fire here is the Richardson fire, 700,000 hectares, massive fire. So all the all the crews were called off these other fires and put onto the Slave Lake fire. So in the globe, there's about 350 to 450 million hectares burned every year, and this is from satellite data. This is about the size of India. We have no clue as to how many fire starts, though people are probably responsible for the vast majority, or the majority of them, about 90%. Largest areas are in grasslands and savannas. Now, fire is a natural and essential part of some ecosystems, like where I'm from, the boreal. So this is work from Mulio and Field, and it just shows decadal fire activity at the global scale. And you can see where Australia, Africa, South America, and the northern areas, you can see there's fire as well. So it's not necessarily how much area burns, it's the impact of the fire. And like real estate, it's location, location, location. And if the fire occurs out in the backwoods, in the bush, it's not as important as those fires that occur near communities and other values. There's been some recent examples of catastrophic fire. Australia 2009, Russia 2010, and the United States the last 3 years, 2011, 12, and 13 have been fairly active. There is recent studies that suggest that smoke-related fatalities are estimated at 330,000 people per year. That's not a myth, that's not a typo, that's published work. Most of the fatalities are in Southeast Asia due to haze. So there's a wide range of fire management activity at the global scale, from very efficient, modern organizations in the Mediterranean, in Canada, United States, Australia, to other places where they still use sacks and brooms to put fires out. Many billions of dollars are spent every year on fire management. And where I come from, we have a fire exclusion policy. Basically, every fire that starts, we try and put it out. That may change because we just don't have enough crews to put out every fire that starts. In Canada and the United States, and we see data here for France, that it's only a few fires that cause most of the problems. The few fires that get over 100 hectares, 1,000 hectares, these big fires are responsible for most of our problems. And in Canada and the United States, they're a very small percent, as they seem to be here too. 1%, 3% of fires cause most of the area burned, most of the problems. And if we can get those fires out through initial attack, then our problems will go away. Now, this is my view of the world in terms of regional fire activity. This isn't an individual fire. This is the amount of fire you'd see in a region like the Mediterranean region of France. And 3 of them are natural. Fuel, how much fuel, how dry it is, the structure. Do you have ladder fuels that carries the fire from the surface into the crowns? The second factor is ignition, humans and lightning. Weather, and I'll be completely, I'm unbiased. I think weather is the most important factor. Things like temperature, precipitation, atmospheric moisture, wind, blocking ridges, stationary ridges, omega blocks. I'm not sure if you're familiar with that terminology, are also very important. Solar radiation is important as well, something that most of our meteor stations for fire weather do not take into account at this point. And then the fourth factor is humans. And we build cities and roads, we fragment the landscape, we have agriculture, so we influence the fuels, and of course we do fire management. So most of my talk is going to be about weather. Johan is talking next, and he's going to talk about the human factor in more detail. Now, I would argue that weather, in terms of the influence, is involved in all 3 factors because fuel moisture is a critical feature of the fuel, and that's dependent on the weather. Fuel moisture decides or determines whether a fire will start and spread. Now, what can we do about this? Well, we can't really control the weather, so our options are fuel, and we can't control the lightning ignitions, and human-caused ignitions is something we can do. And many countries have a good prevention program, education starting right at school age, restricted fire zones, reduce or eliminate industrial activity during periods of high fire danger. And of course, there's fuel modifications. In Canada, we have something called Fire Smart. The United States has Fire Wise, and perhaps you have something equivalent in the Mediterranean. But we reduce fuels, we modify fuels, we change fuels, and Canada is such a vast area, we can't treat the forest, so we treat areas just close to areas of interest, of value around communities, for example, like Slave Lake. So briefly, I'm going to talk about fire-climate interactions. Most of my talk's about fire weather, but fire-climate, there are cycles that we see in temperature, precipitation, and fire. And some of these, there's a number of papers related to ENSO, El Nino Southern Oscillation, Pacific Decadal Oscillation, Atlantic Oscillation, and Atlantic Multi-Decadal Oscillations. These all influence the weather, and by that, they also influence fire activity. One thing I'd like to point out is that recent work has found that our jet stream is changing. Our jet stream is that band of fast-moving air about 10, 12 kilometers above the Earth, and sometimes if you're flying a plane, if you're going with it, you go fast. If you're fighting against it, you're going slow. The temperature difference between the equator and the poles in the northern hemisphere, summer and winter, is decreasing, which means the jet stream is weakening. Now, what this means is, like in a slow-moving river, you get eddies, and so there's areas of stagnation, areas that gets lots of rain, you get lots of flooding, like we've had in Canada and Colorado, but areas of drought where you got lots of fire. We've had massive fires in Quebec this year, 1.5 million hectares in a few weeks. And this is because of stagnation, where you get a blocking ridge, warm, dry weather that sits over a region for 7, 10 days or longer. And projections are that this is going to continue, which means our weather is going to be more variable in the future. And this is an area of ongoing research, and we're just starting to get some handles on this. Now, you've seen something similar to this. This is from the NASA website. The website's listed there. And you can see we've been warming up and some stagnation now, which gets the media and the skeptics going. But we have to look at the longer-term trends. Now, this is also from NASA. And this is observations from the global network of stations. The year is in the bottom, and temperature scales in the bottom as well. And watch as we get into the late 70s and 80s how global temperature. These are observations, and these are from stations that are not from urban areas. And you can see that the world is a much warmer place than it used to be compared to the last 100 years. Now, GCMs, global circulation models, global climate models, whichever acronym you prefer, suggest increases, and we've seen some of these models already, anywhere from 1 to 6 degrees of warming in global mean temperature by 2100. Greatest increases are generally over land, though with the Arctic Ocean going to seasonal sea ice, there will be big changes there as well, and generally in winter and spring. Now, what is really important is this variability. Extremes are supposed to change. And I'll give you an example of wind. The average wind speed is not supposed to change. Most models have it kind of about the same in the future, but in terms of extremes, there's going to be more extreme wind events, and that is a significant concern for fire. So these just show one model. This is the Canadian model and actual observations over North America, and you can see a fair bit of warming, especially in Canada and Siberia. So just before I came here, these were things that are appearing in the media. One's a forum in science, managing forests and fire and changing climates. And the other is from Time magazine, Let It Burn, Changing Firefighting Techniques for a Warming World. And a lot of this is a response to the Yarnell disaster where 19 hotshot firefighters died in a fire. And this is what we're starting to see appear in the media now. So this is an animation, and this is from the Canadian model. And this is just one of many scenarios, but it just gives you an idea in terms of temperature, which we have a lot more confidence about in terms of warming versus precipitation. But the years in the center up there, and 2060, 2070, and scales goes up to 6 degrees Celsius warming. There are areas off Labrador in the southern oceans where there may be some cooling, but this is these models are anywhere close to reality, it's going to be a much warmer world. Now, we've done some work in Canada looking at area burned and projecting to the future. This one used the Hadley and the Canadian model, and we found about, the model suggests a doubling of fire activity in Canada by the end of the century. And just to put in context, Canada has experienced a doubling in fire activity since the 1970s, and we say this is because of human-caused climate change. And despite increases in fire effectiveness and increases in fire management coverage area, that we've had a doubling of area burned. This is work by Mike Volshy and others, and he suggests for Western Canada, Alaska, increases of 2.5 to 5.5 times increases in area burned. This is work done by Nathan Gillette et al., and he related area burned in Canada to temperature and then human-caused temperature increases and found that they were significantly related. Now, fire and temperature, why is this so important? And we've seen some of this in talks already, and there's 3 reasons for it. First, evapotranspiration increases with warmer temperatures, and it's not a linear increase, it's a non-linear. So what we're finding in terms of, we use the Canadian Forest Fire Danger Rating System in Canada, of course. In terms of FWI codes, FFMC, DMC, and DEC, for every degree of warming, you need about a 10% increase in your precipitation to compensate for this increased evaporation. Most of the models where they do have increases in precipitation don't have enough to compensate for this warming. So fuels will be drier, which means it's easier for fires to start and spread. Second, the warmer it is, the more lightning we have, and in Canada and Siberia, lightning fires are important. Third, for temperate and boreal regions, the warmer it is, the longer the fire season. So this is some recent work that was published in Forest Ecology and Management, and it's a global study. We use the Canadian Fire Weather Index, something called a daily severity rating. I'm not sure if you use that operationally in France. It's a function of the FWI, and it's an indication of the amount of effort required to put a fire out. Okay, Williams and Van Wagner did the work a number of years ago. So we used 3 different models, 3 different scenarios, and we did it by decade up until 2100. And I'll show you the maps. And this is where models agree. If you see a red, that means all the models agree that there's going to be an increase in this cumulative daily severity rating. And this is by mid-century. This is using the A2 scenario, just for example. By the end of the century, it's almost unanimous. Everyone's saying that DSR is going to increase, which translates it's going to be harder to put fires out. Now, you may not know how much is it going to increase. Well, if you see large increases in red, that's a tripling of this severity rating. And you can see maybe hard to see, the yellow lines are 1.5 and 2 times, and the red line is 2.5 times. And focusing on the Mediterranean area, and it's going by decade, and by the end of the century, it's suggesting that the severity rating will increase by a factor of 3. Now, this is all weather-based and does not take into account vegetation. This is just the FWI system. Fire season length anomalies. Once again, all the models seem to agree. This is A1B, and by the end of the century, of course, some regions using a temperature-based criteria have a full year fire season already. So, fire season length, red is over 20 days. That's mid-century, end of century, and it looks like, according to this, that fire season length will increase over 20 days in most of Southern Europe, most of Europe for that matter. So, I don't have a crystal ball, but here's a guess. What's the future going to look like? And this is work done in Canada by a colleague. We're going to see more area burned in many areas where weather is a controlling factor. There's going to be more fire occurrence, generally. Fire seasons are going to be longer. Fire intensities and severities, more recently, it looks like they're going to increase as well. Now, in terms of greenhouse gases, fire and carbon are related through combustion directly into the atmosphere. Many hydrocarbons go there. After fire, there's lots of dead vegetation that decomposes, that releases greenhouse gases. And of course, where you have stand replacing or stand renewing fires, you get a mature stand being replaced by a young stand that has different carbon dynamics. Peat, which may not be a concern here, but in parts of the globe, peat it's a legacy store of carbon that's been building up over thousands of years. It's sitting there and it's becoming vulnerable to fire. And it can release significant amounts of greenhouse gases. Work done by Sue Page in Indonesia suggested that peat fire emissions were equivalent to 20 to 50% of global fossil fuel emissions. The peat reserves in Canada and Siberia dwarf Indonesia. So there's a great potential for positive feedback. And this was related to earlier. So the warmer we get, the more fire we get, the more emissions we get, which means it gets even warmer. So this is getting near the end of my talk. So it's a kind of a bleak picture, and listening to some of the earlier talks, it looks bleak for this region as well. Well, health and safety is priority 1. The Canadian Forest Fire Endangering System was developed about 40 years ago. things have changed for fire managers and land managers, and it's in the process of being revised, enhanced, updated. But this is a 5 to 10 year project. I'm part of it with Mike Watton and others, and we're working on it, and we're about 3 or 4 years into the process. But improve systems that will give extra guidance to people fighting fires. Options, fuel treatments like we've talked about, but the risk is going to increase, especially in North America where we have a lot of people. The wildland urban interface has been increasing significantly there. And many of our firefighters are trained to deal with wildland fires, but they're not trained to deal with structural fires. And there's a completely different set of training required. So, fire and weather are strongly related. A warmer weather will have more extreme weather and more fire. And changes in fire may be one of the early impacts of climate change. There will be more impacts. There will be more slave lakes, Colorado Springs, and etc. Fire management is challenging. It's going to be even more challenging with this future. And there's a potential for positive feedback. Say two. Thank you.